Okay, here's us. Um, Apologize, I didn't realize I did not post all of worksheet A, or I guess I did A. I did not realize B was part of it, but it was all multiple choice. So real quick, let's hit those answers, okay? Also, keep in mind, guys, I think it's good for you guys to not necessarily know which one's right, but which ones are wrong and why, okay? I think that's just good learning and practice and just because you never know what you're going to see on the test, right? So real quick, one was C, 2 was D, 2D, 3C, 4B, 5B. Is that right? Yeah. And then 6C. And 7 was A. Oh, woo. 8 was D. And then 9 was C. Oh, 10. 10, C. Good. So out of worksheet A or B, what do you need help with? Anything? Something I better explain. So I went back as soon as you guys left. I knew that something wasn't right about figuring out if it was going to negative infinity or positive infinity. Let me just kind of, this is where my mind was going. Even when I was going over the notes, it was starting to work like, I don't think this is the way to do that. And so, where did I put that? Watch, look, blank white screen. Welcome to blank white screen. So this is my thinking, right? Here we have a y-axis and an x-axis, okay? And let's just say we got a vertical here. And let's say I got a horizontal here. Well, if I plug in a number right here and it's positive, that doesn't tell me if I'm headed to, right? It could be here or here. So if it's here, I'm going up to positive infinity. If it's here, I'm going down to negative infinity. So that's why my mind was thinking, I'm not sure that that's the way to do that, right? So after you guys left, I had another class. Of course, my mind didn't work then, but then I got a prep. And that's when I started thinking, okay, we got to do something different than just plugging in the next number like we did with our greater than, less than. It's fine. It's fine for that because you're just seeing if you're above or below the axis. And that's fine. Because even if the asymptote's here, I mean, you're either above or below it. But trying to figure out if we're going to infinity or positive infinity, I think the best thing, this is 3, I think the best thing to do is plug in like 2.9, something that's really close to it. And again, you don't care what the value is, you're just kind of seeing if it's going to positive or negative infinity. So which number was that? What was it, 7, 8, and 9? Were those the 3 that we were really somewhat concerned with, that I said don't worry about, right, as you guys were leaving? But then that's when I did post a video on that real quick. I wouldn't expect you guys to do all that, but you do need to know how to do this. And so if you would, what was number 7? Something else.
X plus 2, and then x minus 6.
On both top?
Oh, yeah. Divided by x minus 3. That's it.
And that's it? Mm-hmm. Okay. And guys, understand this too. This is like, you can make these things absolutely brutal. I mean, you can make rational functions, good gosh, awful. I mean, you could have 6 vertical asymptotes. No way would we ever get to something like that. I think the max we will see is 2. Because by then, if you understand 2, then you understand 6. If you understand 1, you kind of really understand 2. But if you understand 2, for sure you'll start understanding 6. And at that point, we're not going to do stuff by hand. We got calculators to do that stuff for us. Knowing what happens, I think, that's the big deal about all this stuff. Not necessarily knowing exactly what it does or those, just kind of understanding, okay, this is what we're looking at here. Bless you. So we're okay with, now this is kind of going into today's lesson, right? But it's using stuff we already know. We know for a fact that -2 is a 0. So if I had a graph, whoops, I need a pencil. If I had a graph, then at -2, this graph has a 0 at -2. So regardless of anything else, what it looks like, I know it hits right there. And it also hits at 6. I don't know if I made 6 of them or not. And then now we also know after yesterday's lesson, or 2 days ago, that +3 is a vertical asymptote, right? So we kind of know that. We also should know that we have a slant asymptote because the degree on top is bigger than the degree on bottom. All that stuff, we're going to have a little quiz over that today, right? And today we're going to find the slant asymptotes. That's what we're going to do in 11 today. So I got a slant asymptote somewhere also. Okay. Well, their question was, I wanted to know the limit as x approaches 3, because that's the asymptote, from both the negative side and as x approaches 3 from the positive side. Okay, and then this was f of x. Understand, guys, you could also see the function right here besides f of x. So you could see x plus 2, x minus 6, x minus 3. Just kind of understand you could see it that way. I would never write it that way because that's a bunch of extra lead. Okay, so as we're approaching 3 from the negative side, I need to know if I'm headed down here or if I'm headed up here. Okay, and so I think the best thing to do is plug in 2.9. And really you're plugging in 2.9999999, but you don't just kind of picture all that stuff. Okay, so 2.9. Now we're starting to get a bunch of decimals, but just kind of follow along as I'm doing this. So 2.9 plus 2 gives me 4.9, or a positive number. And then 2.9 minus 6 is going to give me a negative number. So this is going to be a positive number. That's going to be a negative number. So on top, I'm going to have a negative number. Okay, and I really don't care what it is because the bottom's going to fix it. And then 2.9, and let's just say it's 2.99999. Minus 3 is a negative number, but it's a really, 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 really small negative number. It's a really, really, really small negative number. And I mean really small. Well, I don't care what number you're taking it by. If you're dividing it by a really, 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 really small number, you're going to get a really, really, really big number, which is the infinities. And so you have a negative over a negative, which gives me a positive. So I'm headed up to positive infinity. Okay. And then on the other side of 3, now we'll plug in 3.01. But really we're plugging in 3.00001. Right? Just on the other side of 3. So here we go with that. Well, when I plug in 3.001, that's still going to be positive. And 3.001, that's still going to be negative. But then this 3.001 is just going to be barely, barely positive, but it's a really, really, really small number. So we still have a negative on top, but now I have a positive on bottom. And a negative, bless you, negative over a positive is always a negative, and it's really, really, really small on the bottom, which makes a really, really, really big number. Actually, it's a really, 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 really small number. Okay? So that's the way you should do these. So, I mean, plugging in 4 will probably still help you, but I think just that makes it a little bit more, I don't know, concrete. I think it's possible for 4 to give you a wrong number. It kind of depends on where the horizontal is. So I think just do it that way, just to be safe. Especially with a slant asymptote. Especially with the slant. Because a slant asymptote, you don't know if they're doing this or they're doing this. I mean, there's tricks that you can know all that stuff, but knowing all those tricks, by the time you remember the tricks and then still maybe remember them wrong, you should have just went ahead and plugged in a number and you got it. Y'all follow what I'm, yeah, okay. With all, I mean, if you do enough of these, there's tricks to know that we'll be up here and up here and down here and down here and doing all, but I think by the time you remember 1,800 different tricks and then maybe remember them wrong, you might as well just plug in a number and just know for a fact what it's doing, which I think is better for you guys. Okay. Y'all okay with that now? I had to fix that. Anything on that homework assignment that else I need to fix or concrete or something? Anything. I can do them all. Can I solve it? Uh-huh. You want me to work it? You want to work number 8? Which one you said, number 8? Let me hit refresh. This is pretty cool. Except yesterday I messed it up and it was changing colors on me. Can you tell me what number 8 is, please?
On the top, x minus 3, x minus 3. On the bottom, x parentheses x minus 3.
Okay, what am I supposed to do with this?
Limit.
As it goes to 3? Now you don't need help? It's okay. That's kind of important, right? So when she gives me the equation, I don't have a clue what we're supposed to do with it. So she said we're supposed to write the limits. As what? Because I mean, if I'm going to infinity, that's a different question than if I'm going to 0 or if I'm going to 3 or all those type of things, okay? So just understand, we can ask anything about those. They're going to probably tell you where they want that limit to go to, okay? But we can have a limit as we're going to anything. I mean, you can have a limit as you're going to 2. There's really not a limit as it's going to 2. It's actually going to an actual value. But that's why they do limits. It's you're approaching something really, really, really close to it. It's like the old x less than 3, right? You're okay as you're getting close to 3 on the left side, but when you get to 3, you're not good because I don't know what it is at 3. Because at 3, I'm not defined. I don't know what it is. So, and that's back in your olden days when you go to the old number line and you do 3, you did a little circle, and then you did this, right? Because I don't know what happens at 3. So the same thing here. I don't know what happens at 0. I don't know what happens at 3. But as I'm approaching it, I know what happens. As I'm approaching it, I know what happens. As I'm approaching this, as the limit gets closer and closer to 3, I'm getting to 0 in this particular case. Okay? So the limit can approach all kinds of different things. At 2, it doesn't approach anything. It's an actual value. So that's why we don't really do limits as we're approaching a non-3 or a non-negative or anything else. The issues we have with this one would be a positive 3 and a 0. A negative 3 doesn't give me an issue because negative 3 is defined. Because negative 3 actually gives me a 0. So as I'm approaching negative 3, I'm approaching 0. As I get to negative 3, I'm at 0. When I get to 0, I'm not anything. I don't know what happens. I'm either going way, way, way to infinity, which I don't know what that is, or I'm going up here to infinity. Okay, hit me.
Do we ever have problems ordering limit statements for holes?
Yeah. Yeah, that was on some of these. Like this one's a hole.
Yeah, but like it's still going to 3, which is still the asymptote.
3's not an asymptote. 3's a hole.
Oh yeah, sorry.
It's okay. Y'all good? I like hearing these good questions because, yeah, 3's a hole on this one. So as you're approaching 3 on this one, you're approaching a point because it's a hole. It's not an asymptote. So you're approaching a point from either side. You're approaching the same point. It's just at that point, I don't know what happens. Okay, somebody, you had a hand? Hit me. Y'all okay with this? I've talked enough? So you're good with it? Okay. 9. Hit me.
Negative 2 over x minus 3 squared.
X what?
Minus 3 squared.
quantity squared? I do that on purpose too, to sometimes hear how you talk math. Because if I write down exactly what you say, sometimes that's not what it is, right? X minus 3 squared is X minus 9 or plus 9. Depends on where, okay. So this particular one, so this one does not have, oh, now say we're starting to put all this stuff together. This one doesn't have an x-intercept because the top will never be 0. Not only do we know that, we know what about the degree on the bottom? It's 2, and the degree on top is 0. So not only does it not have an x-intercept, the x-axis is the asymptote because it's x equals or y equals 0 for the horizontal asymptote because the degree on bottom is bigger than the degree on top. What were you supposed to do to this one? As it approaches 3. So as we're approaching 3. Okay, so 3 is an asymptote. 3 is an asymptote. And sometimes, guys, it might be beneficial to write this like that. Sometimes, especially if you have like 1 on top, right? If you have 1 on top, then that sometimes helps me realize that I'm still going to have 1 on the bottom, so it's still going to be an asymptote. Okay, so this particular function has an asymptote at 3. Okay, has one at 3. So again, we'll do the same thing as we're approaching 3. So I'll go over here and I want the limit as x approaches 3 from the backside, and the limit as x approaches 3 from the front side. Left side, right side, whatever you want to call it, right? So here at negative 3, now, this is where you can start doing some tricks, right? This one's squared. So instead of this one like doing this and this, it's really going to do this or this, right? Because squares bounce things, right? No matter what I put in this bottom, it's always going to be what? No matter what I put in there, it's always going to be positive because you're squaring anything. So I don't care what I put in there for x, I got to square the whole thing. If I square the whole thing, I'm going to get positive. So the bottom's always going to be positive and the top's always going to be negative. And if the top's always negative and the bottom's always positive, I'm always going to get a negative. And we know this is an asymptote. And if it's always going to be a negative, there's no way to go up to positive infinity. Okay, this is just thinking all through this whole problem without really doing plugging and chugging. Now, if you can't think like that, and that's okay if you can't, we'll just plug and chug. So we'll plug and chug to 2.9. So if I plug in a 2.9, I got 2.9 minus 3, which is a negative number. And a negative number squared is a positive number, and it's going to be a really, really small number. But I'm going to square it. But if I square a really, 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 really small number, it's still really, 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 really small. I know it doesn't, well, but you squared it. I don't care. It's really, really, really small. It makes it really, 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 really small. It makes it really small faster. So you got a number divided by a really, really, really small number, which actually makes it a really, really, really big number. Except in this case, it's a really, really, really small number because it's a negative. So I'm headed down to negative infinity, and I'm headed down to negative infinity on both of those. Okay? And again, the squared should somewhat tip you off like, it's probably going to do the same thing. We kind of have some bouncing going on or something like that, right? And you guys learned, I don't know how long ago, right? Negative over positive is a negative slope. And if you got a negative slope, you're going downhill. In this particular case, we got both of them down here. If that was a positive, guess what? Both of these would be going up. Okay? I do it, and I have a horizontal at 0, so I almost have a picture of this graph, really, because it's just going to do that. I mean, it's sketch. I don't have any idea where this goes or where this is, but that's why we have calculus. I can find the y-intercept really good, too, just by plugging in 0. Right? It'd be negative 2/9. Okay. Sorry. Yippee, yippee, yo. Questions? Question? What else now? What else? Hit me.
So on the limit statements, when there's something besides the asymptote and the denominator is not infinity.
Something beside you got a specific or?
Like on number 2, it has the extra x. Is that what makes it a different number than infinity or negative?
I want to say no, but hit it to me again one more time before it. Whoops. Wait. X minus 3, x plus 3.
Over x.
Okay. So this x, all it does is make me have a horizontal at 0. So I got a horizontal. So I could have said find the limit as we're approaching 0 from the negative side and from the positive side. And the reason why they have to do the negative and the positive side, because you might actually approach a different number. Okay. What's neat about holes is I really don't have to say negative or positive side. Because as you approach a hole, you're approaching the same value. As you approach a hole, you're approaching the same value. I really don't have to say from the negative or from the positive side. That's the definition of a continuous or a non-continuous function. That's the definition of finding the derivative, which is calculus. You can't find the derivative of something if you approach something different. So if you approach the same thing, you can find the derivative at that point. You don't care, but that's what you can do. So at 0, we just have a vertical asymptote. So that could be a different question. As we approach 3, it's actually just a hole. Does that answer your question? Or did I talk to me about what your question was now? I'm sorry.
Well, what made the difference between infinity and 2?
Because it's a hole. It's because it's a hole. If it didn't have, if this was plus also, then it would be infinity or negative infinity because it's an asymptote. Good? Good. As you start doing more and more of these, you start having some aha moments and, oh yeah, I remember this. And that's what makes this hard is every one of them is different. I mean, we can't just say, if you do it this way, it's the same thing over, and it's not the same thing over and over and over again. They're different. They're different. These aren't linear functions where you pretty much either have a positive slope or a negative slope and a different y-intercept. I mean, it's not. You can change these things all over the place. Okay, great questions today, guys. What else you got? I'm telling you, you can learn more probably from the next day of questions than you can trying to do the homework, I think. Yeah, hit me.
Can I know where he'd be?
I got that pulled up. No, I don't. Not on this. I got it on this. 9? This one? We might be in trouble because I didn't even look at this. Okay. Let R be a rational function with the following properties. So as I'm approaching negative or 4 from the negative side, I get -5. That must tell me I'm having a hole. As I approach 2 from the positive side, I'm at negative infinity. That probably tells me I have an asymptote. And as I'm approaching infinity, I'm at -1. That tells me I have a horizontal asymptote. How do you know all that stuff? Well, I'm just as I'm approaching in positive infinity, I'm getting closer and closer to -1. That's got to be a leveled off deal. That's got to be an asymptote there. So which of the following could be an expression? This is one of those where you can have 30 different answers, but only one of these could be. Okay? I mean, it's possible to give you 2 or 3 of them, but they won't. Okay? And this is what they'll try. This will be a multiple choice type question. They wouldn't have you come up with one because I'm not going to grade 200,000 papers with 200,000 different possible answers. Y'all follow what I'm saying? They're not going to do that to you because they're not going to do it to the grader. So it'd be a multiple choice type question. Okay. So that being said, let's go over here. Let's see what color I got going on here. Gray. Okay. So as I'm approaching 4 from the negative side, I'm getting to -5. So that has to be a hole. At -5 has to be a hole. So I'm going to stop right then at 4, I better have a hole. I don't have a hole here. That's infinity. This is either infinity or negative infinity because that's an asymptote. This one could be a hole. This one could be a whole, and this one could be a whole. That's why I say sometimes knowing which one's not right is just as well as, or better, just as good as not knowing which one's wrong. Okay? And then as I'm approaching 2, I'm approaching an asymptote. And how do I know that? Because it's infinity. And it's negative infinity, but that has to be, so positive 2, which is x minus 2, has to be an asymptote. Well, this is a whole, but I already knew this one was wrong, so I'm not even looking at this one anymore, right, if this was a test. It's an asymptote here, it's an asymptote here, it's an asymptote here, so that one doesn't help me any. I don't get rid of one, okay? This one is now what, -1. So that is, and then we said that was a horizontal, because as I'm going out to infinity, I'm at -1. So that must mean the degrees are the same. If the degrees are the same, then we have a horizontal asymptote. And if it's at -1, that must mean they must be the same coefficients. They just, one of them has to be negative. So we have to have, so we have a degree up here of 2 and a degree down here of 2. But this one's positive and this one's positive. I mean positive, right? The coefficients are positive. I'm approaching -1. This one has a degree of 2 and this one has a degree of 2 and this one's negative. So this is a possibility. This one has a degree of 2 and this one has a degree of 2 and this one's negative. So this is a possibility. No, it's not a possibility because this coefficient is a 5. And 5 over 1 is not 1. So we had to narrow it down to C. So again, instead of sometimes looking for which one's right, look which ones are wrong, and then you know it's not that one. Yep. I can do them all. Which one? 8. We'll do this one, you probably got to get going. Polynomial has a 0 at 1 with a multiplicity of 2. Holy cow. Has a 0 at 1 with a multiple. I don't want that. I don't want that. Try again later. That's good. A 0 at 1 with a multiplicity of 2. That must be in my numerator. Okay? A 0 at 1 with a multiplicity of 2 has to be in my numerator. The polynomial g of x. Oh, this is f of x. Okay? G of x has a 0 at 1 with a multiplicity of 3. Yuck. G of x has a multiplicity, of 3. Which of the following functions has a whole at 1? Yeah, and see how they've done, what the heck is h of x? Oh, h of x has a 0 at 1. H of x has a 0 at 1. Yay? So if I need a whole, a whole at 1, that must mean I better have an extra one up top. No, I'm sorry, I better not have I got to cancel. Okay, I got to cancel. So I can't have an extra one on the bottom. I can't have an extra one at the bottom. So this one says f of x over g of x. So if I put f of x over g of x, that means I have an extra one on bottom. Knowing which ones are wrong, might as well just tell me which one's right. This one says h of x over g of x. Put this over this. Heck no. I got 2 asymptotes, which is not really possible. Okay? If I put h of x over f of x, nope, got an extra one on bottom. Got to be that one because the other 3 are wrong. G of x over f. G of x over f. 3 on top, 2 on bottom. There's an extra one on top. You're okay. All the bottom ones go away. Good enough? This is, if I put this over this, that's a linear function with a whole at 1. It's a linear function with a whole at 1. That's what it is. All that crap over all that crap is nothing more than a linear function, because these two are getting these 1, and really all you're left with is x minus 1. It just can't be 0. Or sorry, it can't be 1. Because if it 1, that gives me a bad job. Yep. It'd be on the x-axis because, yeah. Yep. So you'll have a y-intercept of -1 and a slope of 1, but the actual hole is right at 0. It's on the x-axis. That's you guys got bonus coverage for that. You good with that one there, Em? Again, sometimes knowing which one's wrong tells you which one's right. You hate it when it's the last one because you might, what if that one didn't work? I did something wrong. Right? But I still like to check that. Okay? Beautiful. Let's get our notes for 1.11. Let's get our notes for 1.11. Whatever. All right, here we go. Quick. 742. All this stuff you know, I'm assuming, except for one thing. So we'll get to that one thing for sure. But y'all know we got 2 days on this, right? So we got 2 days on this. I'm thinking about just not even getting to the second part and just kind of getting to all the stuff you do know. We'll see how it goes. We got h of x is equal to f of x over g of x. So again, we're talking about a rational function, okay? We know that g of c equals 0. Then it has a vertical asymptote at 0, right? We already know that. So here we have, now we're starting to get into a little bit less, I don't want to say learning, and more of using a lot of stuff we know, okay? So here's where they put h of x is x squared minus 4 over x squared plus 7x plus 10. So they're starting to combine all these polynomials instead of factoring them for you. So I told you at some point, you got to know how to factor, you got to know how to factor, you got to know how to factor. And most everything is going to factor, because if it doesn't factor, you have to use the quadratic formula, and we're not testing to see if you know how to use the quadratic formula. We're not really testing to see if you know how to factor, although, okay. So h of x is this. Write an equation for h of x in factored form and find any values of x where it has a hole or a vertical asymptote. So we got to factor it, right? Hopefully you guys probably already have it done. X squared minus 4 is one of those nice ones. X plus 2, x minus 2. And you can put x minus 2, x plus 2, right? It doesn't matter. I just always put the plus first. X squared, 7 and 10. Luckily, it's x squared. 10 can be 10 and 1 or 5 and 2, but I need 7, so luckily it's 5 and 2. That's not that hard. And they're both positive. Again, all I'm doing, I call it my happy face. I need this and this to get to the middle. And so I just make it a puzzle. I'll make it a puzzle until I get there. Okay. Luckily, this one's a pretty easy puzzle. Boom, 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 boom. Factored form. So here's the factored form right there. Equals h of x. Okay, that's factored form. Hole. There's a hole at -2. I don't know exactly how they want that. I would think they would want a point, but if you put a hole at x equals -2, you're okay, I think, because they didn't tell me how they wanted to put it. So I don't really like that personally, because to me, x equals -2 tells me it looks like a vertical asymptote. But I think they're okay with x equals -2. If you know for a fact where the hole is, we'll put it that way. We know we need to plug in -2, but we can't plug it in here and here because we'll get 0 over 0. So we just kind of hide that part, and we put -2. -2 minus 2 is -4. -2 plus 3, I'm sorry, -2 plus 5 is 3. So the whole is actually at -2, -4/3. So you could put -2, -4/3. What they want, I don't really know. I will tell you this. If you put x equals -2 and you put -2, -4/2, you will get it wrong. Y'all follow what I say, right? Because you put the wrong one. Well, what if they want that? You got it wrong. What if they don't want that? You got it wrong. If you put extra stuff and it's wrong, it's wrong. Okay? So just be careful about that kind of stuff. Make sure you just answer their question. Vertical asymptote, we're bad at -5. And that should be an equation. This is like a no-brainer. You don't have to guess what they want on that. That's x equals -5. Don't put -5 by itself. That's bad. Find the domain of H. This should be fairly easy because we've already established we have a hole and we have an asymptote, and that's the only thing that the domain cannot be. It can be everything else. So the domain will go from -infinity to -5. It can't be -5. We will go from -5 to 2, -2, sorry. It can't be either one of those. And then we will go from -2 to infinity. Okay, and it can't be any one of those. The mistake that students might mess up is forgetting the middle part here. The mistake that they might do is put -2 and then -5. That's bad. It's always low, big. I'm not sure. I'll check with my grader friends, Miss Mims and somebody over at West. I used to accept -infinity, infinity. X cannot be -5 or -2. I used to accept that because my college professor used to accept that. But I don't know if they want it like this or if y'all okay with that? I think they'd be okay with either one. You're telling me it can't be those things, you're good. It can be everything else. But I'll check to make sure that that's acceptable before we go on. If you put it on your test and I don't check with that, I don't tell you, I'll accept it. Okay, beautiful. Here we go again. Example number 3, write it in factored form. Write it in factored form. I've got x squared minus x minus 12, x minus 4, x plus 3. X cubed, x squared, x. Take an x out. And then you got plus 1 minus 20. Plus 1 minus 20. And be careful, guys. They will hit you if you don't put k of x equals, because it says, plain as day, write an equation. There's a difference between an equation and an expression. The expression does not have to have an equal sign. Equation does, right? And the equation is equals. So remember that, okay? Just they'll ding you if they say an equation and you don't put it equals. They're not going to ding you the entire thing, but they're going to ding you. Find any zeros. All right, now you got, zeros. That's when the top is 0. Okay, that's when the top is 0. So the zeros are 4 and -3. Whoops. They're not 4 and -3 because it can't be 4. So the only 0 is -3. And you might put it as a point, and you might say x equals -3. I don't know which one they would want on that. Okay? If it says where are the zeros, I would put x equals -3. Y'all okay with what the question is, right? Sometimes you just got to look and see what they're asking. Where are the zeros? X equals -3. Find any values where it has a hole. We decided it has a hole at 4. Okay, if we want to know exactly where it is, we'll plug in 4. 4 plus 3 is 7. 4 times 4 plus 5 is 9. 9 times 4 is 36. Yuck. So it's at 4, 7, 36. So it's almost 1. Not even close to 1. It's like closer to 0. Find any vertical asymptotes. There's 2 of them. 0, -5. Find any horizontal asymptotes. Degree on top is, and sometimes on those guys, I'll go back here. Sometimes it's better to look at that here than it is over here. The degree on top is less, Bobo. Bigger on bottom, 0. Y equals 0. Horizontals are Y's, verticals are X's. Hit me. It does kind of mean that, yeah. You'll catch that? If I got a horizontal asymptote at 0, no, it doesn't, because we got 2 verticals. So it hits 0 in the middle part. So let's see, how do I explain this without losing you guys? Great golly, knucklehead, not supposed to ask good questions. Okay. So you probably were taught or mentioned at some point, right, a horizontal asymptote it doesn't cross. It can cross a horizontal asymptote, especially if it's 2 horizontal or 2 verticals. Horizontal asymptotes are for, like, as I'm going to infinities. So it can do all kinds of different crap in the middle. I've seen one cross it, and then it comes back up and levels out. So horizontals are for infinities. Okay with that? It's for infinities. You can cross them several times, but as I'm going to infinity, I'm just getting closer and closer and closer to that value. So that, my guess is that's what happens here, because I have 2 of them. My guess is the 0's in there, it's going to hit it in between it. Man, that was a great question. Almost got me. Find the domain. We can do the domain fairly easy. Negative infinity to -5, -5 to 0, 0 to infinity. Or negative infinity, positive infinity, can't be 0, can't be -5. Yep. Oh, 4. Cuss. Go back to this. I was just looking at that. Right? Go back to this. Hey, that right there, guys, is telling you there's a degree of 3. Right? There's a degree of 3. So there's 3 zeros or 3 issues we have in the denominator. So we got to have, well, we're going to end up with 4 different brackets or 4 different parentheses. Okay? Great, great. And then they want me to plug this up into my calculator. And so, guys, these are equivalent. This one and this one are equivalent. It's probably easier to plug in the original than it is the factored, because you got all kinds of parentheses going on the factored. Whereas the non-factored, you only have 1 set of parentheses over 1 set of parentheses. You got to put in parentheses, though. If you don't put in parentheses, it's going to mess up. So open a parentheses, put the top, close the parentheses, divided by, open parentheses, put the bottom, close the parentheses. If you want to do it in factored, you got to open parentheses, and then open parentheses, close, open, close, close. Divided by open, x times open, close, close. Right? Again, either way you want to do that, but it's probably easier just to go over there. Sketch it. But I can almost sketch it without the calculator. All right, here we go. Example number 4. Do I need, we're okay with them prints. I'm not doing that on a calculator. I'm not spending time on that. Write an equation in factored form for f of x. Luckily, it's in factored form. Okay? I know I better do that. When I see write an equation, I'm almost going to go right in and do that. Right? Because if you don't do that, it's wrong. Okay? We know we got a horizontal asymptote, we got a vertical asymptote, we actually have a hole. I got a hole, I've got a horizontal, and I got a vertical. Okay? So we know we have a rational function. So that's going to help me there. I know that I have a vertical at what? 2? So if I have a vertical at 2, I'm going to put x minus 2 on the bottom. Okay? And then from there, I'm not going to worry about the horizontal till the end. I'm not going to worry about horizontal till the end. I know I have a hole at what? 1, 2, is that 4? So if I have a hole at 4, this is x minus 4 and an x minus the 4. Okay? So we're good there. Now, I have a horizontal at, luckily it's -1. It's -1. And right now the degree on top is 1 and the degree on bottom is 2. So that's actually putting it at 0 because it's bigger on bottom. I need it at 1. So I need another x on top. I can't just put an x. I think I need to just do a squared. Can I do that?
It looks like it needs it.
Say again?
It looks like it needs it.
Meets at 3. Huh? Oh, yeah, I don't care. Y'all okay now? Except now what's my degree on top? 2. My degree on bottom is 2. What's my coefficient on top? 1. What's my coefficient on bottom? 1. And where's my asymptote? Whoops. Yep.
If you plug in 4 from the full, it won't equal the y.
Oh, what is the, oh, it's supposed to be like 1/2?
Yeah.
-1/2. It won't?
Wait, 4, 0
I'll get 0 over.
over 2.
Okay. Dang it. Cuss. I can't put an x though.
X minus 3. X minus 3 because it meets there too.
It meets where? 3?
Yeah. The x minus 3 because now it's 1.
Oh. Huh? Y'all see that? Huh? Dang it. Cuss. I gotta start doing some homework. I keep coming in this class blind Neil. You know, blind Neil. No. Yeah, I got an x-intercept at 3. So that means it gives me an x minus 3. Well, that made it really nice. Now we're good, right? Now I don't need to worry about anything else. That was easier. I'm trying to make it harder. This class is easy. Told you. I'm trying to make it hard. That's why they don't let me make tests. Because everybody fails those. Happy, happy, joy, joy. And now the 1/2 is there, or the -1/2. Let's see if I can mess this one up. Graph is shown, write an equation, g of x. Okay, that's going to give me part of it. All right, and I bet I got a fraction. And I got a vertical at 1, 2, 3 again. It looks like I got a vertical at 0 too. Doesn't matter where you put it, right? Put it. I got a hole at 2. Whoops, that should be minus. Let me fix that. I can fix those. I have a horizontal at 0. I'm good there because my degree on bottom is bigger than the degree on top. My whole is at what, 2 1/2? I don't have a 1/2. X minus 1. Oh, I got another 0. Oh, see, I about forgot that stupid thing again. Got another 0. So x minus 1 is a 0. Is the degree on bottom still bigger? Whew. Degree on bottom still bigger, so I'm still at 0. Okay, now I hope I don't have any other x's. And now let's see where my hole is. Now if I plug in 2, that's 0. So if I plug in 2, that's 1 on top. That's 2, and that's 1. I'm there. I don't need to do anything else. They'll do that a lot. Yep.
Wouldn't that be a negative number?
Don't tell me that. Okay. There, I'll fix that. Here's a little tricky trick. Y'all see that I'm kind of in this quadrant and this quadrant, which is a negative slope. That tells you they're going to have a negative in it. That's a little tricky trick of the trade. If it was here and here, you wouldn't have that negative, you'd have that positive. Those get kind of hard. Those get hard. You got to hit everything and just see what all. They could make it really hard, but most time they're going to at least, help you out quite a bit. Okay, how are we doing? 12. I got 3 minutes. I can do this. Yeah, I'm going to do that. We'll do that Thursday because we got 2 days to do it.